Yes, it is a code requirement to paint the floor 3 feet out underneath electrical equipment such as panel boards, transformers, and other similar electrical installations. This requirement stems from the National Electrical Code, specifically Section 110.26c. This section addresses dedicated equipment space and working space, and while it doesn't explicitly mandate painting, it implicitly necessitates a clear and permanent delineation of the dedicated space. The purpose of this dedicated space is to ensure that electrical equipment has sufficient room for maintenance, repairs, and safe operation. Painting the floor serves as a visual indicator, preventing the area from being used for storage or other non-electrical purposes. Consider a typical electrical room. Without clear markings, it's easy for personnel to place boxes, tools, or other items in front of the electrical panels or transformers. This obstructs access and can create a safety hazard in the event of an emergency. If a fault occurs and quick access is needed to shut down the equipment, any obstruction could delay the response and increase the risk of injury or damage. The 3-foot distance specified is generally considered a minimum clearance. Local jurisdictions or specific project requirements may dictate a larger area. It's crucial to consult the local amendments to the National Electrical Code and any applicable project specifications. The type of paint used is also a consideration. It should be durable and resistant to wear and tear, as the floor in an electrical room is likely to experience for traffic and equipment movement. Epoxy-based paints are often a good choice due to their durability and resistance to chemicals. The color of the paint is usually a light, contrasting color to make the dedicated space easily visible. White or light gray are common choices. In addition to painting, other methods can be used to delineate the dedicated space, such as floor tape or physical barriers. However, painting is often preferred because it is a more permanent and visually clear solution. The code requirement to maintain a clear and unobstructed working space around electrical equipment is not just about convenience, it's about safety. It protects electricians, maintenance personnel, and other workers from electrical hazards. Furthermore, it helps to ensure the reliable operation of electrical equipment by preventing overheating and other issues that can arise from inadequate ventilation or obstructed access. In summary, the practice of painting the floor 3 feet out underneath electrical equipment is a code-driven requirement designed to ensure safe and reliable electrical installations. It provides a clear visual indication of the dedicated equipment space, preventing obstructions and facilitating maintenance and repairs. Always consult the latest edition of the National Electrical Code and local amendments to ensure compliance with all applicable requirements. It's important to consider that while the National Electrical Code, specifically Section 110.26, emphasizes dedicated equipment space and working space, the act of painting the floor isn't explicitly stated as a mandatory requirement in all situations. The intention behind the code is to maintain a clear and unobstructed space for electrical equipment, and painting is one commonly accepted method to achieve this. However, the specific interpretation and enforcement of this can vary depending on the local authority having jurisdiction or OJ. In some jurisdictions, inspectors may insist on painted floors as the primary means of demarcation, while others may accept alternative methods as long as they effectively define the dedicated space. These alternatives can include durable floor tape, physical barriers like bollards or low walls, or even a combination of methods. The key is that the demarcation must be clear, permanent, and easily recognizable, preventing the area from being used for storage or other purposes that could impede access to the electrical equipment. When planning an electrical installation, it's always advisable to consult with the local AHJ to determine their specific requirements for dedicated equipment space. This can help avoid costly rework later on and ensure compliance with all applicable codes. Furthermore, it's essential to understand the rationale behind the code requirement. Maintaining a clear and unobstructed working space around electrical equipment is critical for several reasons. Firstly, it provides safe access for electricians and maintenance personnel to perform necessary repairs and maintenance. Electrical equipment often requires periodic inspection, testing, and component replacement. If the working space is cluttered with obstacles, these tasks become more difficult and time-consuming, increasing the risk of errors and accidents. Secondly, a clear working space facilitates quick access in the event of an emergency. If a fault occurs or a fire breaks out, it's crucial to be able to quickly shut down the affected equipment to prevent further damage or injury. Obstructions in the working space can delay the response and potentially exacerbate the situation. Thirdly, maintaining adequate ventilation around electrical equipment is essential for preventing overheating. Many electrical components generate heat during operation, and if this heat is not properly dissipated, it can lead to premature failure or even fire. A clear working space allows for proper air circulation, helping to keep the equipment cool and operating within its design parameters. In addition to the 3-foot clearance requirement, the National Electrical Code also specifies minimum headroom requirements for working space around electrical equipment. This ensures that personnel have adequate space to stand and move around safely while performing their tasks. The specific headroom requirements vary depending on the voltage of the equipment and the configuration of the installation. It's important to consult the National Electrical Code for the specific requirements that apply to each situation. Furthermore, the National Electrical Code addresses the issue of foreign systems in the dedicated equipment space. It prohibits the installation of piping, ducts, or other equipment that is not directly related to the electrical installation within the dedicated space. This prevents interference with the electrical equipment and ensures that the working space remains clear and unobstructed. In conclusion, while painting the floor 3 feet out underneath electrical equipment is not explicitly mandated in every situation, it is a widely accepted and effective method for complying with the code requirement to maintain a clear and unobstructed working space. It's important to consult with a local authority having jurisdiction to determine the specific requirements and to understand the rationale behind the code. By adhering to these requirements, we can ensure safe and reliable electrical installations that protect personnel and prevent equipment damage. Let's delve a bit deeper into the nuances of National Electrical Code Section 110.26 and its implications for dedicated equipment space. While the code doesn't explicitly say paint the floor, it outlines the requirements for working space around electrical equipment operating at 600 volts or less. This space must be kept clear and accessible, and it must meet specific dimensions for depth, width, and height. The depth of the working space is determined by the voltage to ground of the equipment and the presence of any exposed live parts on the opposite side of the working space. For example, if the voltage to ground is 150 volts or less, the minimum depth of the working space is 3 feet. If the voltage to ground is between 151 and 600 volts, the minimum depth is 3 feet 6 inches. And if there are exposed live parts on both sides of the working space, the minimum depth increases to 4 feet. The width of the working space must be at least 30 inches, or the width of the equipment, whichever is greater. This ensures that there is enough room for a person to stand and work safely in front of the equipment. The height of the working space must be at least 6 feet 6 inches, or the height of the equipment, whichever is greater. This provides adequate headroom for personnel to move around and perform their tasks without having to stoop or bend over. Now let's consider the practical implications of these requirements. Imagine an electrical panel board installed in a mechanical room. The panel board is fed from a transformer located nearby. To comply with the National Electrical Code, the area in front of the panel board and the transformer must be kept clear and accessible. This means that there should be no storage boxes, tools, or other obstructions in the working space. The working space must also meet the minimum dimensions for depth, width, and height as determined by the voltage to ground of the equipment. If the floor in front of the panel board and the transformer is not clearly marked, it can be difficult to determine where the working space begins and ends. This can lead to confusion and potential violations of the National Electrical Code. Painting the floor is a simple and effective way to delineate the working space. By painting a 3-foot wide strip around the perimeter of the equipment, you create a visual boundary that clearly indicates the dedicated equipment space. This helps to prevent obstructions and ensures that the working space is always kept clear and accessible. In addition to painting, other methods can be used to delineate the working space, such as floor tape, physical barriers, or even a change in flooring material. The key is to choose a method that is durable, visible, and easily maintained. It's also important to consider the color of the paint or tape. A bright, contrasting color will make the working space more visible and less likely to be overlooked. White, yellow, and orange are all good choices. Now let's talk about some common misconceptions about the National Electrical Code. One common misconception is that the National Electrical Code is a law. The National Electrical Code is not a law. It is a set of recommendations developed by the National Fire Protection Association. However, the National Electrical Code is often adopted by state and local jurisdictions, and when it is adopted, it becomes law. Another common misconception is that the National Electrical Code is a one-size-fits-all document. The National Electrical Code is not a one-size-fits-all document. It is designed to be flexible and adaptable to a wide range of situations. The National Electrical Code allows for some degree of interpretation and discretion on the part of the electrical inspector. A third common misconception is that the National Electrical Code is only for electricians. The National Electrical Code is not only for electricians. It is for anyone who designs, installs, or maintains electrical systems. This includes engineers, architects, contractors, and even homeowners. In conclusion, painting the floor 3 feet out underneath the electrical equipment is a widely accepted and effective method for complying with the National Electrical Code requirement to maintain a clear and unobstructed working space. It's important to consult with the local authority having jurisdiction to determine their specific requirements and to understand the rationale behind the code. By adhering to these requirements, we can ensure safe and reliable electrical installations that protect personnel and prevent equipment damage. Let us address some scenarios where the interpretation of painting requirements might differ. In an industrial setting, the presence of heavy machinery, frequent equipment relocation, and ongoing facility modifications often necessitate a more flexible approach to dedicated space demarcation. While painted lines remain a viable option, they may be supplemented or replaced by more robust and adaptable solutions. For instance, heavy-duty floor tape, available in various colors and widths, provides a readily adjustable means of defining work areas. This is particularly useful when equipment layouts are subject to change. Furthermore, physical barriers such as bollards, guardrails, or even strategically placed equipment cabinets can serve to delineate the dedicated space while simultaneously providing protection for the electrical equipment. In such environments, the emphasis shifts towards ensuring the long-term visibility and maintainability of the chosen demarcation method. Regular inspections and maintenance are crucial to identify and address any wear and tear or accidental damage to the markings or barriers. In contrast, commercial buildings, such as office complexes, retail spaces, and hospitals, often prioritize aesthetics and cleanliness. While the fundamental requirement for dedicated space remains, the methods employed to achieve it may need to be more visually integrated with the overall design of the building. In these settings, the use of subtle color variations in the flooring, such as a slightly darker shade of gray or a contrasting tile pattern, can effectively define the dedicated space without being overly intrusive. Alternatively, recessed floor markings or embedded lighting can provide a discreet yet effective means of demarcation. The key is to strike a balance between functionality and aesthetics, ensuring that the dedicated space is clearly identifiable while minimizing any negative impact on the building's overall appearance. In residential settings, the application of dedicated space requirements is often more relaxed, particularly in older homes where electrical panels may be located in confined spaces such as closets or basements. While painting the floor is still a valid option, it may not always be practical or necessary. In such cases, the focus shifts towards ensuring that the area immediately surrounding the electrical panel is kept clear of obstructions. This may involve relocating storage items, rearranging furniture, or simply reminding occupants to avoid placing anything in front of the panel. The key is to educate homeowners about the importance of maintaining clear access to electrical equipment for safety and maintenance purposes. Regardless of the specific setting, it is crucial to remember that the ultimate goal is to prevent accidental contact with energized equipment and to ensure that qualified personnel have unobstructed access for inspection, maintenance, and repair. The choice of demarcation method should be based on a careful assessment of the specific environment, the type of electrical equipment involved, and the applicable codes and regulations. Always consult with a qualified electrical contractor or inspector to determine the most appropriate solution for your particular situation. Now let's address the selection of appropriate paint. Selecting the correct type of paint for marking dedicated electrical spaces is crucial for ensuring durability, visibility, and long-term compliance with safety standards. The choice of paint depends on several factors, including the type of flooring material, the level of foot traffic, the potential for chemical exposure, and the desired aesthetic appearance. For concrete floors, epoxy-based paints are generally considered the best option. Epoxy coatings are known for their exceptional durability, chemical resistance, and adhesion properties. They form a hard, protective layer that can withstand heavy foot traffic, spills, and abrasion. Epoxy paints are available in a wide range of colors, allowing for easy customization and compliance with color coding requirements. Before applying epoxy paint, it is essential to properly prepare the concrete surface. This typically involves cleaning the surface to remove any dirt, grease, or loose particles, followed by etching or grinding to create a slightly rough texture that will promote adhesion. A primer may also be necessary to ensure proper bonding between the paint and the concrete. For other types of flooring, such as tile, vinyl, or linoleum, alternative paint options may be more suitable. Acrylic latex paints are a good choice for these surfaces, as they offer good adhesion, durability, and color retention. Acrylic latex paints are also easier to apply and clean up than epoxy paints. However, they may not be as resistant to chemicals or heavy foot traffic. Before applying acrylic latex paint, it is essential to clean the surface thoroughly and apply a primer that is specifically designed for the flooring material. This will help to ensure proper adhesion and prevent the paint from peeling or chipping. In addition to the type of paint, it is also important to consider the color and finish. As mentioned earlier, bright, contrasting colors such as white, yellow, or orange are generally preferred for marking dedicated electrical spaces. These colors are highly visible and easily recognizable, even in dimly lit areas. The finish of the paint can also affect its visibility and durability. A glossy finish will reflect more light, making the markings more noticeable. However, a glossy finish may also be more slippery, which could pose a safety hazard. A matte or satin finish will provide a more subdued appearance and may be less slippery. Ultimately, the best choice of paint will depend on the specific requirements of the application. It is always advisable to consult with a paint supplier or contractor to determine the most appropriate product for your needs. Remember to follow the manufacturer's instructions carefully when applying any type of paint. This will help to ensure that the paint adheres properly, dries evenly, and provides the desired level of protection and visibility. Regular inspection and maintenance of the painted markings are also essential for ensuring long-term compliance with safety standards. Touch up any areas that have become worn or damaged, and reapply the paint as needed to maintain a clear and visible demarcation of the dedicated electrical space. By paying careful attention to the selection and application of paint, you can create a safe and efficient working environment for electrical personnel and prevent accidental contact with energized equipment. Now let's discuss the implications of the Americans with Disabilities Act, also known as ADA, in relation to the marking of dedicated electrical spaces. While the ADA primarily focuses on ensuring accessibility for individuals with disabilities, it also has indirect implications for the design and layout of electrical rooms and other areas containing electrical equipment. The ADA requires that all public accommodations and commercial facilities be accessible to individuals with disabilities. This includes ensuring that there are clear and unobstructed pathways to and from all areas of the facility, including electrical rooms. The dedicated space around electrical equipment must be kept clear of obstructions to allow individuals with disabilities to access the equipment for inspection, maintenance, or repair. This means that the painted markings or other demarcation methods used to define the dedicated space must not create a tripping hazard or otherwise impede access for individuals with mobility impairments. For example, if floor tape is used to mark the dedicated space, it must be securely adhered to the floor and must not have any loose edges that could cause someone to trip. Similarly, any physical barriers used to define the dedicated space must be designed to be easily navigable by individuals with wheelchairs or other mobility devices. In addition to physical accessibility, the ADA also requires that facilities provide effective communication for individuals with disabilities. This may include providing signage in braille or large print, or using audible alarms or visual signals to alert individuals with hearing or visual impairments. In the context of electrical rooms, this may mean providing signage that clearly identifies the location of electrical equipment and warns of potential hazards. The signage must be accessible to individuals with visual impairments, either through braille or large print. It is also important to consider the color contrast of the signage to ensure that it is easily visible to individuals with low vision. Furthermore, the lighting in electrical rooms must be adequate to allow individuals with visual impairments to safely navigate the space and perform their tasks. The ADA does not specify specific lighting levels, but it does require that facilities provide sufficient illumination to ensure accessibility and safety. In summary, the ADA has several indirect implications for the design and layout of electrical rooms and other areas containing electrical equipment. Facilities must ensure that the dedicated space around electrical equipment is accessible to individuals with disabilities, that signage is provided in accessible formats, and that lighting is adequate to ensure safety and visibility. By complying with the ADA, facilities can create a more inclusive and accessible environment for all individuals, including those with disabilities. Let's explore the role of routine inspections. Conducting routine inspections of electrical installations is crucial for identifying potential hazards, ensuring compliance with safety standards, and preventing equipment failures. These inspections should include a thorough assessment of the dedicated space around electrical equipment to ensure that it is being properly maintained. During an inspection, it is important to check for any obstructions in the dedicated space, such as storage boxes, tools, or other items that could impede access to the equipment. Any obstructions should be removed immediately. The inspector should also verify that the painted markings or other demarcation methods used to define the dedicated space are still visible and intact. If the markings have become faded or damaged, they should be touched up or replaced as needed. In addition to checking for obstructions and maintaining the markings, the inspector should also assess the overall condition of the electrical equipment. This includes looking for signs of damage, such as cracked insulation, loose connections, or corrosion. Any damaged equipment should be repaired or replaced immediately. The inspector should also check the ventilation around the equipment to ensure that it is adequate to prevent overheating. Vents should be clear of obstructions, and fans should be functioning properly. Furthermore, the inspector should verify that all safety devices, such as ground fault circuit interrupters, or GFCIs, and surge protectors, are functioning correctly. These devices are designed to protect personnel and equipment from electrical hazards, and it is essential to ensure that they are in good working order. The frequency of routine inspections will depend on the type of facility and the nature of the electrical equipment. However, as a general rule, inspections should be conducted at least annually. In some cases, more frequent inspections may be necessary, such as in industrial facilities where electrical equipment is subjected to heavy use and harsh environmental conditions. The results of each inspection should be documented, and any deficiencies should be corrected promptly. This will help to ensure that the electrical installation remains safe and reliable over time. In addition to routine inspections, it is also important to conduct inspections after any major repairs or modifications to the electrical system. This will help to verify that the work was performed correctly and that the system is functioning properly. By implementing a comprehensive inspection program, facilities can minimize the risk of electrical accidents and equipment failures and ensure the safety of personnel and the reliability of their electrical systems. Now let's address the topic of electrical safety training. Providing comprehensive electrical safety training to employees is essential for creating a safe working environment and preventing electrical accidents. This training should cover a wide range of topics, including the hazards of electricity, safe work practices, the use of personal protective equipment, and emergency procedures. The training should be tailored to the specific needs of the employees and the type of electrical equipment they work with. For example, electricians and maintenance personnel will require more in-depth training than office workers. The training should emphasize the importance of following safe work practices at all times. This includes energizing equipment before working on it, using lockout/tagout procedures to prevent accidental energization, and maintaining a safe working distance from energized parts. Employees should also be trained in the proper use of personal protective equipment, or PPE, such as gloves, safety glasses, and insulated tools. The type of PPE required will depend on the voltage level and the type of work being performed. Employees should be instructed on how to inspect their PPE before each use to ensure that it is in good condition. The training should also cover emergency procedures, such as what to do in the event of an electrical shock or fire. Employees should know how to shut off the power, call for help, and administer first aid. Regular refresher training should be provided to ensure that employees retain their knowledge and skills. This training should include updates on any changes to safety regulations or procedures. In addition to formal training, it is also important to provide ongoing safety reminders and reinforcement. This can be done through safety meetings, posters, and other communication channels. By investing in electrical safety training, facilities can reduce the risk of electrical accidents, protect their employees, and ensure the reliability of their electrical systems. Training is a critical component of any comprehensive electrical safety program.